โอเคนะครับlast time we started the topic of functions, right? We discussed the okay, we start with this one. We discussed the definition of function. Okay, what is the similarity and differences from relation? Okay, one thing that you should know by now is that every functions are relations. Okay, but some of the relations, only some of the relations are functions, right? And we discussed about the definition of functions. Okay, for a relation to be a function, it does have to have two very important properties. Okay, which I'm not going to repeat it here, but basically, you have that every element in the domain of that relation has to have a relation to some of the elements in the range or in the codomain of that relation. Okay, and the second one is that if you have for every element in the domain, it has to have only one relation to the uh, member in the codomain of a function or a relation. Okay, which we have discussed. I have given you some example of the relation which is a function, some of the relation that is not a function. Okay, for this two example, a few more here. Okay, and a few more here, and then we discuss even more about the definition or the notation of a function. In a relation, we have the relation that map from set A to set B, but we haven't really defined the set A, what the set A is. Okay, so this one we define a name for set A, right? We call it a domain. Okay, domain. So if you have like usually when we draw left one set on the left and the other set is on the right. Okay, we call the left one or the input one. If you think of a function, the left one would be the input. Okay, the right set or the right circle or the right side of the function would be the output. Okay, so A is the input, B is the output. Okay, or you can think of it as a domain and a codomain. Okay, domain is something that is going to be put through a function, and a codomain is something that can be possible outcome or possible output of that function. Okay, if you think of that, you know, give you some clarity. So A is going to be mapped. Okay, so in this one you have A1, A2, A3, A4. This one we have B1, B2, B3, B4. Okay, this one going to be map. Okay, map. Let's say function F. For each element, it will be mapped. A1 might be mapped to B1. A2 might also be mapped to B1. A3 might be mapped to B3, and A4 may be mapped to B3, B2, say. Okay. So A will be the domain, right? B will be codomain. And the set of B1, B2, B3 will be the set of a range, right? Okay. So last time we discussed about how to find domain, codomain, range. Okay. So usually when you are given a definition of a function, like for example, this one, f is a function from set of integer to a set of integer. F of x is equal to x to the power of 3. Okay. So in this definition, you can clearly see what's the domain is, what the codomain is, and what's the range. Well, the range you might have to figure it out a bit because it can be clearly see here. But you can say that the domain is the set of integer because from the look of this, you can say that okay, this is the set on the left hand side or the set of the input or the set of the domain. This one you can see that the set of the codomain is this one, which also similarly a set of integer. So you can write codomain set of Z. But then the range is the actual set in the codomain that are actually used or actually have a link from the members in the domain. So in this one, I'm just saying that, okay, the range is a set of something, let's say y is equal to the x to the power 3, where x is the integer number, something like this. Okay, and so on, which I'm not going to repeat. Okay. I think we finished with one-to-one already. Okay. Oh, last time we also discussed the one-to-one function. Okay. One-to-one function. So basically, it's like one member on the domain will be connected to one member of the codomain. That's one-to-one. Okay. Sometimes you can see in like at a really old math textbook, you might see like injective, one-to-one or injective function. Basically, it's the same thing. Okay, so basically, roughly the definition of one-to-one function is that every members in the domain will be connected or will be mapped to one member in the codomain, basically, right? For example, the example down here, you have set A with members of A1 and A2. You have the right set here with the set B. You have B1, B2, B3, and then you have A1 mapped or have a relation, or it has a function from A1 to B1, and then A2 from B2 to B2. Okay, so because every member in set A, which is A1 and A2, only connected or only mapped to only one element in set B1, okay, and and they're not mapping to the same elements in B1. I mean in B, okay. So A1 is mapping to B1, A2 is mapping to B2, so they are different, which means this is a one-to-one function, okay. Last time we discussed the formal definition of the function with saying that if f is a one-to-one function, then for every members x and y in the domain set A, if f of x is equal to f of y, then x of y, okay? And then from this definition, we can use it to prove one-to-one function. For example, I think we did some example here. Oh, this one. So for this one, well, let me just add a page. So actually, when we want to show or to prove that a function, let's say function f is 1 to 1. As you can say, we have two choices. One is that to show or to prove that f is not, right? And then to prove f is function. Last time we discussed about this a little bit, right? To show that f is function 1 to 1, or f is not a function 1 to 1. This one is easy. Well, if f is actually not really a function 1 to 1, to prove that f is not is easy. This one a little bit harder to show that f is actually 1 to 1, because the definition say that for every members in the domain of this of set A that is under function f, if it's 1 to 1, which means that f of x, okay, f function f of x, if it's equal to function f of y, then x is equal to y. So which we will have to prove that later, but to show that it's not, it's easy. For this one, I just should move this one a bit. Oh, so to show is not just what do you do? Just give one example where x is not equal to y, but f of x is equal to f of y. Okay, that's easy. For example, For example, let's see. Okay, which one is not one to one? Oh, okay, this one. Let's say for example, g of x is a function from integer to integer. G of x is equal to x squared. Okay. So to prove that this is not, you have to show one example. Let's say x is equal to 1 and y is equal to -1, right? So we find an example where x and y are not equal, but then we can substitute or plug x and y in g of x, which we get a f, let's say g of 1, which is equal to 1 squared is equal to 1, and then g of -1, which will be equal to also 1. Okay, this show that g of 1 is equal to g of -1. So this one just show that there is, well, at least one example that we found here, that there is an example where x and y not equal, but then g of x and g of y is equal, right? So this one show that f is not 1 to 1. Okay. This is easy. Just keep example. Let me just find another one that is not 1 to 1. Where we give x squared. Okay, I can think of one more. For example, let's say h of x from set of real number to set of real number. H of x equal to not absolutely, absolute x time, let's say absolute y. I mean absolute x. Okay, so let's say x is equal to 1, or let's say 2, y is equal to -2, f of 2 is equal to 2, not f, sorry. This one should be h of -2 will be also 2. So as you can see that x is not equal to y, but then h of x is equal to y. So this shows that h of x is not 1 to 1. But of course, there are some examples that actually 1 to 1. So you can find, you will not be able to find any example that give you this this behavior, that you find two numbers that are not equal, but then you plug it in that function, and then you get an equal value. Okay, you will not find that. So after plug it in, maybe trying to find example, but then you couldn't think of anything. So my suggestion would be maybe it's a one-to-one function. So if it's a one-to-one function, we come back to this one to show that f is a one-to-one function. I should say here, not each function is one to one function. Okay. So to show that it's one-to-one function, here's what we do. Okay, because the definition say that if f is one-to-one function, you means that for all members, let's say, for example, x and y in the domain set, let's say A, if f of x equal to f of y, then x is equal to y. Okay, this is how you're going to show if it's a one-to-one function. For example, let's say that g of, I will use g h, let's say f again. F of x is equal to real number to real number. Let's say that f of x is equal to x plus 2. Okay. So you can try and substitute some, let's say x equal to 2, y is equal to -2, but then you will not get f of x equal to f of y. Okay, you can try, let's say 1 minus 1, nope, 3 minus 3, nope, it's not going to work, right? You cannot find any example that are not equal in values, but then after you plug it into the function, you get an equal value. You will not be able to do that. So maybe this one is a one-to-one function. So if it's a one-to-one function, here's what you're going to do. You have to imagine that there are two members in this, in from the domain, two members, any members, okay, any members, because in the domain, it's a set of real numbers. So there are infinitely many numbers in that set, right? There are infinitely many numbers in that set. Okay, you can imagine that that you choose two numbers from that set, any numbers. Okay, any numbers, it can be any numbers. But let's say that the two numbers that you choose is, let's say, x and y. X can be anything, but it has to be real number. Y is also can be anything, but it has to be real number. Okay. So now you have to use the properties of the one-to-one functions that say that, let's say that f of x is equal to f of y, okay, then x equal to y, which means that you can do like, let's say that you have to assume that f of x equal to f of y, okay, and then check if x equal to y. If it is equal to y, then this is a one-to-one, okay. That's how we're gonna do 1, 2, 1. This is how we're gonna do it, okay. So for the example, f of x, okay, let's say that x and y is any number from the real number set, okay. Let's say that f of x is equal to f of y, So as you can see, f of x is equal to, from the definition of this f of x set, so it's equal to x plus 2, and f of y is equal to y plus 2. So because this one, we assume that they are equal, so we can say that f of x is equal to x plus 2 equal to f of y equal to y plus 2. So we have x plus 2 equal to y plus 2. So from this one, can you conclude that x must be equal to y? Yes, we can, because we just delete both side with two numbers out, right? So you have, what you have left is x equal to y, right? Which means that f of x is 1, 2, 1. Okay. A little bit longer, okay, but necessary. Okay. uh, uh, Notes a little bit to show that function is one to one, right? You cannot give example, okay. You might say that, Ajahn Kap, I'm trying to find 10 examples that make this one not one to one, but I couldn't find any example from that 10 example that I tried to think of. So is this must be one to one? Well, it may be, but because there are like tens of thousands of, well, infinitely many numbers left that you haven't tried. Maybe in one of those infinitely many number will be false, or will be, like give as false result, or will show that f is not one to one. Okay, so you cannot just give one example. For example, this one, remember this one, g of x is equal to x squared, right? We know that earlier this one is not one to one, right? This one is not one to one. Right? This one is not one to one. But if we try to give example, let's say x is equal to oh, no, this one is not what I'm thinking of. Okay. Oh, okay. Let's say that t of x is equal to function, let's say, I can't think of one example that infinitely many number give you a true result, but then one number will give you a false result. Okay, I can't think of that right now, but be more careful that to show that function is one-to-one, you cannot. Okay, give example. Like even though you give like 10, 20 examples, if your domain set is infinite set, then it won't be matter. Okay. Any question on this one? Ah, okay. I think where's the chat? Oh, okay. No one. Okay, now that's a one-to-one, right? Next one is onto. Onto is a lot harder than one-to-one. Okay. What is the onto function? Let's just can I just answer this quick email? Just 2 minutes. Okay. Onto function. So your requirements or your compulsory skill that you should need to be able to acquire here is that when you look at one function, you should be able to tell like, is this onto function or is this not onto function? Okay, what is an onto function? Onto function can be described using these pictures. Okay, this one. Okay, so f is a function from a to b. Okay, as you can see that the left hand side is set a, the right hand side is set b. The left hand side has a member a, b, c, d, and the right hand side is a member 1, 2, 3. Okay, so as you can see that the A is mapped to number 2, B is mapped to number 1, C is mapped to number 1, and D is also mapped to number 3. Okay. So one-to-one function is basically saying that if this function and the codomain or the members of the codomain are mapped in every members, okay, this one is onto function. Okay. Or you can also say that codomain is equal to range. Okay, codomain will be equal to range if it's a onto function. Okay. Why is it equal to range? As you if you remember that when we say codomain, okay, it's the set of possible outcome for this function, right? But when we say range, it's basically saying that a set of all members that are actually got a match from some of the members in the domain, right? So I need to move a bit, right? So basically, when it's onto function, if you draw a picture, or if you can draw a diagram of an onto function, you can easily see that, oh, this one is onto function, or this one is not onto function. Okay. So this function f that you can see in the slide here is definitely onto, right? Because every members in the codomain are used. Okay? That's easy. Okay. So let's say that I have more examples that I do. Okay, but I will give you one more example. So let's see that. There may be some tricky question. For example, let's say that A and B, so G. Okay, this one is A, B, C, 1, 2, 3. Okay, let's say 1, 2. Let's say that A is mapped to 1, B is mapped to 2. The question is G a onto function? Is G onto function? Most of you probably answer yes, but and this one is probably a tricky question. Is G onto function? Well, let's look at it. Okay, the definition of onto function is that every members on the codomain has to be used. Basically, used to mean like there is a map or there's a link from one of the members in the domain to the members of that in the codomain, right? So as you can see, oh, A is mapped. Yes, B is mapped. See, but this is not onto function. I have G is not even a function, right? G is not a function because as you if you remember, if G is a function, every members has to be mapped. I mean, every members in the domain has to be mapped. So A is mapped, okay. B is mapped, but C, you can see C. C is what? It's not mapped. It's actually linked to anyone in B, in set B, right? So C is not mapped. So G is not even a function. So to add is G an onto function? No, it's not. It's not a function. Okay. So this one is kind of tricky. So if I draw you a diagram, I'm pretty sure that you all can determine if, oh, this is onto, this is not onto. Okay. Basically, just look at the members in the codomain. Okay. If it's all mapped, it is onto. Now, what if you cannot draw a diagram, right? Oh, life would be much easier if we all can draw a diagram, but sometimes you can't. Okay. For example, let's say f is a function from set of real number to real number, okay, and then f of x is equal to x plus 1. Okay. Question is f of x is onto, okay. So similar to the one-to-one, if you remember, there are possible answer, right? Yes, it is, and no, it isn't, right? And similarly to one-to-one function, okay, if you want to determine if f is a one-to-one function, to answer no, it's easier because this one you just keep one example that f of x is, well, one example, I should be more specific, that y in codomain is not mapped. Okay, so you just have to find one element or one member in your codomain that is not used or is not mapped. For example, you have like, if you can draw a diagram, A, B, and then G, and then A, B, C, D, 1, 2, 3, 4, and then you have this, you have this, you have this, and then you have this. Well, if you can draw a diagram, you can give it, oh, here it is, D is not mapped. So this one is not on two, okay? For example, okay, let's see example. Let's say that g of x is a function from integer to integer. Okay? G of x is equal to, let's say, x to the power 2. Okay. The problem is this one onto function? You can say, oh, it's easy. Because you have to find one example that you will not be able to find any x. Well, you have to find one y value that you won't be able to find x that substitute into the function and then give you the value of y. For example, let's say y is equal to -1. what number or what integer number that you can square, okay, raised to the power 2, and then get the result as -1. Is there any number that you can do that? No, right? We cannot find any numbers because any numbers to the power 2 will be positive, right? But y is -1, which is still in the codomain, right? So y is -1, -1 is basically is negative number. So you will not be able to find any x value that will be able to find a limit. If you try to if you try to if you try to draw a pictures, okay, for the g of x is equal to x squared, okay, you get something like this. So let's say this is the integer number. So it's an integer number. You can have like 0, 1, 2, 3, 4, 5, 6, -1, -2. To do dot dot dot, -3, -4, -5, -6, dot dot dot. So similarly, 0, 1, 2, 3, 4, 5, 6, dot dot dot, -1, -2, -3, -4, -5, -6, dot dot dot. Okay, so 0 to the power 2 is 0, 1 to the power 2, 1, 2 to the power 2, or 8, so somewhere there. 3, somewhere there. 9, somewhere there. 5, somewhere there. 6, somewhere there, right? -1 to the power 2 is 1. 2, -2 to the power 2 is, oh, sorry, I thought it power 3, sorry. 2 is 2 to 4, 3, 9, okay. -2 is 4, -3 is up there, -4 is up there. As you can see that, oh, there is tons of number that you can give example that will show that there is no map, right? -1 is 1, -2 is also another one, -3, and so on and so forth. Even you can find like y is equal to 2. You will not find any x value that is to the power 2. It's an integer number that is to the power 2, and then you get 2. It's not possible, right? So this one is G. This one is not true. Okay. So to answer not onto, just give one example. One example that will, one example means that you find the value of y, okay, that you will not be able to find the value of x, substitute into the function, and then get the value. Okay, another example. I don't know if the example. Oh, okay. The second one. Okay. So this let look at the number 2 first. Okay. Number 2 is the function h. Okay. From the set of integer number to the set of integer number. Okay. H of x equal to 4x minus 1. Okay. The problem is, the question is h on 2 function? Okay. So the first thing you should always do is trying to find an example to make it not on the function. Okay, so you have to find the value y. Note here. So find y such that it cannot be. So say, let's say y is equal to what? Okay. Let's say y is equal to 0. Just guess. So you substitute 0 into the function. So h of x is 0 to 4x minus 1. So y equal to 0. So you get 0 equal to 4x minus 1. What is the number that x can be such that when it's multiplied by 4 and minus 1, you get 0? And remember, x has to be integer number. Okay. I don't think we can find it. Well, if x is not integer number, you can probably find that, okay, x can be 1 over 4, right? But now x is forced to be integer number. So x is 0, you get minus 1, x is 1, you get 3, right? So if x is if x is 0, you get 3, x is 1, you get 3, Oh, sorry. If x is 0, you get -1. Sorry. X is 1, you get 3. If x is -1, you get -5. Right? So no 0, no 0, right? How? So this means that you can find the value of y such that x cannot be found, right? No x. So this h is 1. Oh, no, is not 2. Okay. So just find one example. Okay, I don't know if we have any more example. Hmm.
อาจารย์ครับอาจารย์ปิดไมค์หรือเปล่าครับ
โอ้ครับสงสัยมือโดนเนี่ยอ่ะนะครับมาดู let's see some example from midterm exam last year นะครับอ่า so this one you are given a function, let's say f function, from the set of real number to a set of integer number, so which means that you can plug in any real number, but what you get is an integer number out from this function นะครับ so this function is function f of x, okay, is equal to, this is a symbol called ceiling, okay, ceiling. So this one is f of x equal to ceiling x divided by 2. Okay. So the ceiling function is the function, well, okay, to, okay. So ceiling function is something like this. Oh, I don't have a ceiling symbol. Okay, let's imagine that the brackets are the ceiling. So the ceiling is that, let's say that ceiling of x is defined as the, the minimum or the smallest integer number that is greater than or equal to x. Okay, the ceiling of x is equal to the smallest integer number that is greater than or equal to x. So for example, you can have ceiling of 1.2, or let's say ceiling of 3. Yes, yes, yes. So what is the smallest integer number that is greater than or equal to 3? Well, that's easy. 3, right? Because 3 is the smallest that is greater than or equal to 3. You can't answer 4 because 4 is not the 4. 4 is greater than or equal to 3, yes, but it's not the smallest. You have 3, right? You cannot answer 2 because 2 is not greater than or equal to 3. Remember, right? We're looking for the number, the integer number that is greater than or equal to the number that in the ceiling operator. Another difficult one would be -2, let's say. The ceiling of, let me, let me share the screen from the iPad. Maybe I can write it better. Okay, let me see. Let's see. Teaching. Okay, let me just set share slide from the iPad. Okay. Okay. So this one will what number is it? Number 4. Okay. Okay, this is what we are. Okay. So we just add one more page here. Okay, I was I was talking about the ceiling function. Ceiling function. Okay. So we use the symbol like like ceiling, like roof, ceiling roof. So something is on top of you. So basically ceiling is something like this. So say ceiling of x is the smallest. Okay. Integer number that is greater than or equal to, let me just use a symbol, then x. Okay, basically. So as you can see, ceiling of 3 would be equal to 3. Okay, ceiling of 1 would be equal to 1. Ceiling of -2, ceiling of -2 will be -2, basically, right? Anything that is already an integer, that's easy. But let's say ceiling of 3.2. What is this? Okay. So what is the smallest integer number that is still greater than or equal to 3.2? Is 4, right? Ceiling of 1.2 would be 2, and ceiling of 2.4 would be, no, of course not -3, right? It's gotta be -2.4. So ceiling of -2.4 will be -2. Okay. So that's ceiling. You also have something called floor function. So you have floor function like this. So the opposite of the ceiling, you have like something like the floor. Okay. So the floor of x is the greatest integer number, or the biggest integer number that is less than or equal to x. Okay. So the biggest or the greatest integer that is still less than or equal to x. Okay. So for example, floor of 3, you get, of course, you get 3. Floor of 1, of course, you get 1. Floor of -2, of course, you get -2. But floor of 3.1, this one you get 3 because 3 is the biggest biggest number that is still less than 3.1. You cannot use 4 because 4 is already bigger than 3.1. You cannot use 2 because even though 2 is less than 3.1, but 2 is not the biggest. You have 3, right? So C floor, not floor, floor of 1.5 is equal to 1. Floor, floor of minus 2.4. My tongue is tidying up. Okay, right? Minus 3. Okay, so that is the floor and ceiling. Okay, coming back to the problem, they ask you, okay, let's define function f. Okay, f from the set of real number to a set of integer number. F of x is equal to ceiling of x divided by 2. Okay, I keep some explanation here again in case somebody forgot about what it is, the ceiling function. Okay, for example, and that. So the question is, what's the question? Okay, find the domain and the codomain and the range of this function. Easy, right? Domain. Oh, we just look back at the definition. So the domain would be the real number, right? The codomain would be the integer number, right? Okay, we can answer this one. So this one would be the real number. This one would be the integer number. And the range. Oh, okay. The range. The question would be, how do we find range? Basically, we have to find any numbers that is in the codomain that that are used, right? Basically, that's the range. The question is range equal to integer number? Or in this case, yes. Okay, because you can find any number in the range, and you can always find the number in the domain that will, once you plug in the function f, you get the codomain. Okay, for example, you can find, okay, let's say I want one, of course you can have like ceiling of 1. That's easy. You can have 2, you can have ceiling of 1.2, for example, right? 1.2, ceiling of say 1 minus 2.4. Okay. Oh, sorry, 4 minus 4. You can have ceiling of, what is it, minus 3. No, minus 4, minus 4.4. Minus 4.4, the ceiling of minus 4.4 is minus 4, yes. So it's the smallest that is still bigger than minus 4.4, yes. So this one range is integer number, okay. Oh, um, okay, we have B, C, D. How about I give you 5 minutes, okay? Trying to think of F is 1 to 1 or and F is on 2, okay? Don't be concerned on the the problem D, okay? Give you 5 minutes. I need some water. Okay, 5 minutes. You can you can try to check if F is 1 to 1 or on 2. Okay, I'm just gonna create a poll here. Okay, so you can all where is it? Poll. No, not poll. Sorry, Q&A. Yes, poll is what is F? 1, 2, not 1 to 1, 2, 1. But not onto not 1 to 1. Okay, let's say okay. So let's take 5 minutes. Okay, maybe you can try to answer that. นะครับทำไมเสียงกล้องมีคนตอบ9 คนไม่มี participation point ไม่มีเดาเลยครับ มานะเอาเอ็นพอแค่นี้ก่อนเอายังมาตอบแล้ว14เอาหรือรออาจารย์มาเอาให้อีก10 วิเนาะเรามาดูเฉลยกันนะครับผมแชร์แล้วยังไม่ได้แชร์แชร์อยู่ไหมไม่ได้แชร์แล้วใช่ไหมครับแชร์ไหมแชร์ไหมอ่าเดี๋ยวมันเตรียมสอบมิดเทอมแล้วนะครับนะครับก็ถามว่านะ determine if f of x is one to one โอเคนะครับโอ้โหอันนี้ก็ หลายคนบอกว่ามูมากนะถ้าใครที่พอจะมีเขาเนาะ one to one คืออะไรนะครับ so basically we have to find and if f is not one to one นะครับ we just have to find one example that is if you can find two numbers that when you plug into the function f you get the same result นะครับอันเนี้ย not one to one เลยนะตัวอย่างก็คือ นะครับ we can find let's say so example let's say x equal to um, 1 okay y is equal to 0.8 นะครับ so f of 1 is equal to ceiling of 1 which is equal to 1 see f of 0.8 เห็นไหมผมขออนุญาตมา เขียนตอบอีกหน้าหนึ่งเนาะไม่เขียน เมื่อกี้เราจะตอบข้อ ข้อ B ใช่ไหมครับเนาะ determine if f of x is 1 to 1 well the answer is no f of x is not 1 to 1 well usually you should answer this maybe last but let's say for example say x is equal to 1 okay and then y is equal to 0.8 you can say f of 1 will be equal to ceiling of 1 will be equal to what is the what is the smallest number that is greater than or equal to 1? It's 1, right? So you get f of 1 is equal to 1 and then f of 0.8 you get ceiling of 0.8. What is the smallest integer number that is greater than or equal to 0.8? So basically it's 1. So you can see that f of 1 is equal to f of 0.8. Okay. This means that you have two values for the input, okay, which are different. But then once you put it into the function f, you get the same output. So this means that f is not one to one. Okay, if you draw pictures, say this is A, this is B, so basically this is 1, this is 0.8, they are mapped to the same number, which is 1. Okay, so this show that is not one to one. Okay, let me see the vote results. Most of them are, oh, most of you answer 1 to 1, but not on 2. Okay. Second highest choice would be not 1 to 1, but on 2. Okay. So what we know that the first answer is incorrect. So most of you got incorrect answer, but that's okay. All right, the second problem, they say that check if f of x is on 2. Okay. Check if f of x is onto นี่ต้องทำไงครับถ้าให้มัน not onto we have to find again อันนี้จะต่างกันเนาะ if we want to check if f is not one to one นะ we have to find two inputs that give one same result เนาะอันนี้ onto we have to find one output that cannot find input for okay one output that you cannot find any input that can produce that output okay so what can we find that you cannot find output for? Remember that f of x is function from the real number to the integer number อันนี้สำคัญนะครับต้องเช็คว่าไอตัว input กับ output เป็นอะไรได้บ้างเนาะ this one is say that input is any real number okay and the output is integer number เพราะฉะนั้นลองหาดูก่อนเนาะ we should check first if maybe f of x is not on true so let's say well so the output or the value of y you can think okay let's say y is 1หาได้ไหมครับ1 x ต้องเป็นอะไรถึงจะได้1เนาะง่ายมากข้างบนก็เพิ่งออกนะครับ x อาจจะเป็น 0.8 ก็ได้นะครับ2 x เป็นอะไรดี x ก็เป็น2ลบ1ลบ1 x เป็นอะไรจริงๆลบ1ได้เนาะลบ20ลอง ยกตัวอย่างมาครับ y อย่าลืมนะ y has to be integer right so you can think of any integer that is the output okay and then that integer will not find any input real number that will once you go through that function f you will not be able to get the output f y เห็นไหมครับใครที่จะสามารถหาได้ค่า y ที่แบบหาค่า x ไม่ได้ครูอาจารย์ครับก็-1อะไรอันนี้ไม่ใช่นะค่า y อย่าลืมว่าค่า y ต้องเป็น integer นะ-1อยู่2ไม่ได้นะค่า y เป็น integer สังเกตได้ว่าทุกค่า output integer ครับมันจะต้องหาค่า x ได้เสมอเลยไหมเสมอเลยแต่อย่าลืมว่าแสดงว่านะมาถึงตรงนี้นะครับมาถึงนี้เนี่ยแสดงว่าอย่าเพิ่งสรุปนะ you cannot conclude that this is onto นะครับ that you can conclude that there is possibility that f is on true you cannot find any example as I said earlier นะครับexamples is used to give a false result or to counter example that this function or this statement is not true นะครับไอตัวอย่างนี้เอาไว้เช็คว่ามันไม่ใช่นะมันไม่ใช่แต่ว่าถ้าจะเช็คว่ามันใช่เนี่ยเราต้องทำแบบนี้เนาะนั้นแต่จริงๆผมว่ามาถึงตรงนี้จริงๆโอเคในเลเวลของเราผมว่าอันนี้น่าจะโอเคนะจริงๆแล้วอันนี้ผมว่าเราจริงๆเรายกตัวอย่างมาสักส่วนหนึ่งเนาะเราจะเห็นได้ว่าจริงๆแล้วเนี่ยถ้าเราก็อาจจะสรุปได้ว่าเนี่ยว่าเราจะเห็นเทรนด์นะว่าfor any y ในจำนวนเต็มเนาะเราสามารถ there is always x นะครับในจำนวนจริงนะครับที่ f of x เท่ากับ y อันนี้หาได้จริงเนาะนี่ลงยกตัวอย่างได้เพราะฉะนั้นอันนี้สรุปได้นะครับว่า f is on true ถ้าข้อนี้ใครตอบ ข้อ2เนี่ยถูกต้องนะครับ24คนมีโหวต9คนนะถูกต้องนะแต่อธิบายหน่อยเนาะตอบถูกตอบผิดเนี่ย ผมว่ายังไม่สำคัญเท่าสามารถอธิบายได้ไหมโอเคนะครับกลับมาสไลด์ต่อเนาะอันนี้น่าจะจบแล้วนะครับตอนนี้ we will call any function that is both one to one and onto นะครับ both one to one and onto we will call it one to one correspondence okay or bijection okay bijection so any function that is both one to one and on to คือ called by เพราะฉะนั้นif there's a ถ้ามีคำถามว่าis f bijection หรือว่าเป็น one to one correspondence นะ basically what you have to do is to check whether it is both onto and one to one ง่ายๆเนาะเพราะฉะนั้นบางฟังก์ชันเนี่ย บางฟังก์ชันที่เราเช็คมาเนาะเช่นอะไรอ่ะอันนี้เราเช็คอันนี้เรามันจะมีบางฟังก์ชันเนาะที่ both one to one and one to จริงๆอันเนี้ย one to one and one to นะครับแต่ว่าผมยังไม่ได้แสดงให้ดูนะเช็คดูได้นะ inverse function inverse function สมมติว่าเรามีฟังก์ชันใช่ไหมครับ let's suppose we have a function the inverse function is the opposite of that function นะครับ inverse ก็คือ opposite นะครับ for example if we have a function f okay, that map from set A to set B and then map from element A to element B f of A is equal to B okay the inverse function will be written as f to the power minus 1 will be equal to the mapping back from set B to set A and then f of inverse or f to the power minus 1 b will be equal to a นะครับก็จะเป็นประมาณนี้เนาะ but the important note that we should note here is that not every function has an inverse นะครับอันนี้ต้องสำคัญนะไม่ใช่ทุกฟังก์ชันจะมี inverse นะครับ only bijection function นะครับเฉพาะฟังก์ชันที่เป็น one to one กับ on to นะถึงจะมีinverse function นะครับง่ายๆยกตัวอย่างนี้นะครับ สมมติว่าเนาะ let's suppose that we have a function f a b เนาะ let's say f มันเป็น a b c มันเป็น one two three เนาะส่วนนี้เป็น one to one function เนาะก็คือ a ไป1 b ไป3 c ไป2นะครับนั้น inverse function ก็จะปุ๊บ map กลับมาใช่ไหม f inverse เนาะมันก็จะกลายเป็น1ก็จะ map กลับไปที่ a 2ก็จะ map กลับมาที่ c เนาะ3ก็จะ map กลับมาที่ b เนาะอันนี้สังเกตง่าย อย่างแรกก่อน first อย่างแรกก่อนสังเกตว่า f เนี่ยเป็น one to one ใช่ไหมครับและ f เป็น on to ด้วยนะใช่ไหมนี่สังเกต1 2 3ใช้หมดเลย one to one ได้ไหมเนี่ย a 1 b 2 c 3 c a 1 b 3 c 2ใช่ไหมเป็น one to one ให้ on to นั้นมี inverse เดี๋ยวมาดูรูปนี้ let's say a b say a b c 1 2 3 4นะสมมติว่า เหมือนกันนะ a เป็น1 b ไป3 c ไป2อันนี้เป็น g ถามว่า g เป็น one to one ไหมครับเป็นเนาะเพราะว่านี่ a ไป1 b ไป2 a b ไป3 c ไป2เนาะเป็นเนาะแต่ g ไม่ใช่ on to เนาะเพราะว่าอะไรเพราะว่าเรายังมี c เลยติดอยู่ไม่มีใครแมปมางั้นใช้ไม่หมดใช่ไหมครับ คำถามคือแล้วถ้าเกิด inverse ล่ะครับ inverse นี่เกิดปัญหาเลยเนาะเกิดปัญหายังไงเอาลองคิดดู inverse เราก็จะแมปกลับใช่ไหมครับ inverse กลับ1ก็จะแมปกลับไปที่ a c ก็2ก็จะแมปกลับไปที่ c 3ก็จะแมปกลับไปที่ b เห็นปัญหาไหมใครเห็นปัญหาคืออ้าวแล้ว4เนื่องจากว่า4 doesn't have any link or any relation or any map from any element in A นะครับมันไม่มีลิงก์ระหว่างนั้นทำให้มันไม่มีทางแมปกลับไปได้ครับเลยทำว่าเกิดอะไรขึ้นครับทำให้ไอ้4ตัวเนี้ยทำให้ g inverse เนี่ยเนาะผมเขียนนี้เนาะ g inverse มันไม่ใช่ฟังก์ชันครับจำได้ไหมฟังก์ชันเนี่ยเขาเรียกว่าอะไรตัวที่อยู่ซ้ายมือหรือตัวที่เป็น input เนี่ยมันจะต้องแมปไปหมดนั่นคือฟังก์ชันเนาะมันจะต้องมีทางไปสำหรับ input นะแต่ลองจินตนาการดูเนาะ g inverse เนี่ยมันแมปกลับเนาะถ้าเรากลับหัวเนี่ยผมแมปกลับหัวด้วยมันออโต้โรเตทให้เนาะแต่ลองจินตนาการเนาะขวามือของ g inverse เนี่ยขวามือเป็น input ซึ่ง1มันก็แมปไปที่ A เนาะ2ก็แมปไปที่ C 3ก็แมปไปที่ B กลายเป็นว่า4ไม่ตรงแบบแสดงว่า G ไม่ใช่ inverse เนาะอันนี้เป็นที่มาว่า เฉพาะนะครับ only bijection เนาะฟังก์ชันจะมี invert นะครับจะมี invert โอเคนะครับอันนี้ก็คือเป็นที่มาว่าทำไมจะต้องเป็นอย่างนี้ตอนนี้มาดู invert เราหาง่ายคือ invert ถ้าเป็นรูปเนี่ยหาง่ายมากใช่ไหมเสียงถ้า invert นี่หาง่ายใช่ไหมครับถ้าเป็นรูปเนาะเป็นรูปเนี่ยอย่างเช่นรูปที่รูป h เนี่ย a h is from h is function from b to b เนาะ h invert ก็เป็นฟังก์ชันจากโอ้นี่ผมเขียนผิดแล้วเนี่ยสไลด์ผิดตั้งจาก b ไปที่ a ใช่ไหมครับจริงๆกำหนดว่า a นี่เป็น b เนาะอันนี้ h invert นี่ก็เลยกลายเป็น b ไปที่ a เนาะเดี๋ยวนะครับอันนี้ง่ายเนาะก็คือถ้าเปลี่ยนเป็นรูปเนี่ย it's simple you just kind of like change the direction of your arrow and maybe swap a place the output can be moved to the input or the output from the right hand side can be moved to the left hand side and the left hand side set which was the output which was the input can be moved to the output ใช่ไหมครับเนี่ยอันนี้ สมมุติว่ามาดูข้อสองกันอันนี้วิธีหาหนวดอย่างแรกก่อนนะครับเพื่อความชัวร์เช็คก่อนนะto อินเวอร์นะต้องเช็คก่อนนะครับเช็คก่อนว่าเป็น bijection ไหมเช็คคร่าวๆก่อนก็ได้นะครับว่าฟังก์ชันเป็น bijection ไหมเพราะว่าอย่างข้อ G เนี่ยเป็นไหมเป็นนะ on to แน่นอนนะ on to แน่นอนอันนี้ลองไปเช็คตัวดูนะอันนี้เป็น bijection เพราะฉะนั้น invert ก็หาโดยการทำไงครับ ถ้าใครจำได้ไหมแอดสไลด์ข้อสองนะครับเช็คก่อนนะครับว่าเป็น bijection นะครับซึ่งอันนี้ yes นะอันที่สองก็คือเราก็สลับใช่ไหมครับเราได้ฟังก์ชัน g of x เนาะเท่ากับ x บวก1นะครับเพราะฉะนั้นจะเป็น y เท่ากับ x บวก1ใช่ไหมครับมีการหาthe way we find the inverse function we just swap x to y y to x right so basically you have x equal to y plus 1 replace every x with y replace every y with x okay then you reorganize it such that it's a y equal to right so you can have y equal to x minus 1 so this means that g of inverse g of x equal to x minus 1นะครับเราก็จะได้แล้วนี่คือ inverse เนาะจำได้ไหมส่วนข้อหนึ่งนะครับข้อหนึ่งก็เป็นข้อหลอกเนาะข้อหลอกก็คือถ้าเราหา inverse เลยนะจริงๆข้อหนึ่งเขียนข้อหนึ่งนะสมมติถ้าเราหาเลยเนาะข้อหนึ่งเป็นอะไร f ใช่ไหม f of x equal to x square นะครับเพราะฉะนั้นถ้าเราหายด้วยเลยนะมันจะเป็น y เท่า x กำลังสองใช่ไหมครับใส่ค่า x เป็น y y เป็น x ใช่ไหมครับเราก็จะได้ y เท่ากับ square root x ฉะนั้น f inverse of x เท่ากับ square root แต่ว่าเนาะถ้าเราเช็คนะครับอันนี้เป็นจริงๆเป็น one to one ไหมไม่ใช่ not one to one เดี๋ยวเราไปเช็คอีกทีก็ได้นะครับจริงๆมีก่อนหน้านี้มีตัวอย่างแล้วเนาะ on to ไหมอันนี้เป็นจำนวนจริงเป็นจำนวนจริงใช่ไหม on to ไหมไม่ใช่ on to เนาะ on to ด้วยเพราะฉะนั้นอันนี้ invert ไม่มีนะครับ no invert ใช่อันนี้ก็เป็นหลอกนะครับข้อหนึ่งเนี่ยเป็นหลอกเนาะ no invert ข้อสองก็หาได้นะครับข้อสามก็หาได้เนาะได้ด้วยนะครับก็เขียนด้วยกันโอเคครับมีคำถามไหมอันนี้เหลืออีกหนึ่งเรื่องท้ายๆนะครับแล้วก็เดี๋ยวมาดูhash function กันเดี๋ยวสัปดาห์นี้หมดแล้วนี่ใช่ไหมครับสัปดาห์หน้าก็สอบแล้วเดี๋ยวผมจะนัดเรียนอีกสักครั้งหนึ่งเนาะเพื่อให้จบฟังก์ชันแล้วก็อาจจะมีเตรียมสอบนะครับเป็น จะเป็นวันเสาร์วันอาทิตย์ไม่รู้เราสะดวกไหมเนาะเตรียมสอบแล้วก็ยังไม่ได้นัดมิดเทอมเลยเนาะแต่นัดมิดเทอมก็ถ้าไม่ทันสัปดาห์หน้าอาจจะนัดสัปดาห์ถัดไปก็ได้นะครับไม่ซีเรียสอะไรเนาะก็เดี๋ยวหนึ่งเนาะเดี๋ยวนัดสอนอีกหนึ่งครั้งก่อนสัปดาห์มิดเทอมนะครับแล้วก็เดี๋ยวเขาผมไปให้โหวตแล้วกันเนาะแล้วก็นัดมิดเทอมเนาะแล้วก็นัดเตรียมสอบเนาะตอนที่จะเตรียมสอบเดี๋ยวผมจะโพสต์ข้อสอบเก่าเนาะย้อนหลังสัก2-3 ปีนะครับให้เราไปลองทำดูนะครับแล้วก็ผมจะเฉลยข้อสอบเก่าเนาะปี2010ไม่ใช่2020เนาะปีอันก็คือชุดนี้นะครับชุดนี้นะถ้าใครไปอยากไปทำก่อนนะครับไปทำชุดนี้ได้นะครับแล้วก็เดี๋ยวเราจะมาเฉลยกันเนาะในตอนที่นัดเพิ่มนะครับวันนี้มีคำถามอะไรไหมครับตอบสไลด์โอเคนะครับไม่มีเนาะก็วันนี้ก็มีเท่านี้นะครับเจอกันเดี๋ยวเจอกันอีกทีตอนที่ผมนัดเพิ่ม